Okay, on these problems, we are going to identify the domain. So, without a graph, there are ways that we can identify the domain of a given function. So, one way is that the domain is just automatically negative infinity to positive infinity for the functions, except for two special cases. When we have the square root function and when we have a rational function, which is basically fractional, where you have variable components in the denominators. So we're going to start with the radical function, the square root function. So with the square root function, remember, what does it mean we're identifying the domain? We're trying to identify what are the values of x that we can input into the function that will give us an output that is also on the real xy grid, okay? So if there's any value of x that we can put into this function that will give us an output that is not part of the xy plane, then we cannot have that x value as in the domain. So when you're dealing with square root functions, anytime you take the square root of a negative, it yields an imaginary value. Imaginary values are complex numbers, and complex numbers are not part of the real plane. And so we have to make sure that any value of x that goes into this function is not less than 0. So when we are trying to identify the domain of a square root function, we set it greater than or equal to 0, and then we are going to solve for x. Okay, so we have a square root is greater than or equal to 0. You want to get rid of the square root, so you square both sides. You raise both sides to the second power. So we get 25 minus 5x is greater than or equal to 0. I'm going to solve for x. I'm going to divide both sides by negative 5. You have to make sure you remember that anytime you divide an inequality by a negative value, it flips the symbol. So x is less than or equal to 5. So if you need to see it so you can be able to do your interval notation, it says x is less than or equal to 5. So all of the values of x that will go into this function that will yield a real output are the numbers that are less than 5. So in interval notation, our domain is going to be negative infinity to 5 with the bracket. And that's it. When we look at the rational expression, we have a rational expression which just means fraction. So we are looking for the values of x that can plug into this function and yield a real output. Well, when you're dealing with fractions, the one thing you cannot have is a 0 in the denominator, because dividing by 0 does not yield an output that is present in the real plane. It is undefined. You cannot divide by 0. So we have to make sure that there are no values of x that are in the domain that could create a 0 in this denominator. So what we do is we are going to set the denominator equal to 0, and that way we can identify the values of x that will not be in the domain. So anytime you have a quadratic, something squared, we're going to have to factor this problem and solve. So factors of 4, 4, and 1, plus, minus, equals 0. So we take each factor and we set it equal to 0. So we get x equals negative 4 and x equals 1. So what we're saying is that the domain cannot contain negative 4 and cannot contain 1. So I like to see it on the number line, because that way I know what I can include in my domain. So it's different from the square root. The square root function gives you the domain. When we do the rational, it's telling us what is not in the domain. So we're going to use every other value for x on the real number line is going to be in this domain except negative 4 and 1. So in interval notation, that looks like negative infinity to negative 4, union with negative 4 to 1, union with 1 to infinity. And that is our domain for that rational function. And that is it. Oh, and don't forget that I love math, and so do you, and you're good at it. Remember that.